All right, so we already did the front side, and I'm gonna hop over to the back side of our notes for today. So this is for 3 and 4, examples 3 and 4 for 1.3. So example 3 says solving equations with no, and I put that in caps, solution. All right, so this says to solve (3 minus 4x) equals -7 minus 4x. So again, I'm going to rewrite it. 3 minus 4x equals -7 minus 4x. So let's look at our like terms. I have a -4x on this side and on this side. And my non-variable or my constant terms are 3 and a -7. And I have that line between. So remember, whatever I do to the left, I have to do to the right. So remember, our first step is to move our smallest variable term. Now you're probably saying to me, my variable terms are the same, so it doesn't really matter which one you're moving at this point. So I'm going to add 4x to both sides. That's going to leave me with 3 equals -7. And you're saying, well, what did I do wrong? You didn't do anything wrong. Remember, the heading says solving equations with no solution. There is no value of x that is ever going to make this equation true. So this has no solution. Some might say no real solution. And that can also be abbreviated by a circle with a slash through it. The best part about equations with no solution, there's no check. So I am going to put that in there for you. So you have no check when you get a result of no solution. All right, example 4, last one. So example 4 is solving equations with infinitely many solutions. We'll talk about that in a minute. Let's look at what it has us doing first. So it has us solving, so it says solve 6x plus 4 equals, and then it has 4 outside 3 over 2x plus 1. So the first thing I'm going to have to do is distribute. But before I can do that, I have to write it out. So 6x plus 4 equals 4 times 3 over 2x plus 1. So again, I'm going to distribute, and I'm going to put them little arrows arrows to remind you what's actually happening. So I'm just going to bring down my 6x plus 4. When I multiply 4 times 3 halves, the 2 is going to cancel with the 4, making this a 2. So it's going to simplify. So I get 2 times 3, and that's going to give me 6x. And then I have 4 times 1 gives me the plus 4. Now, you probably are already noticing what's happening here. I've got a 6x and a 6x. I've got a plus 4 and a plus 4. Still have to keep going. I'm moving my smallest variable term first. I'm dealing with my variable term, so I'm going to subtract 6x from both sides. And that's going to give me 4 equals 4. So unlike this one, where that's never going to happen, now you have 4 equals 4. Well, doesn't that have the ability to always be true? So because this is always true, you're going to have infinitely many solutions. Some people will say the infinity symbol solutions. Some say all real numbers. So all real numbers are going to make that statement true. Okay? Now, since we put this is always true, I'm going to actually add it up here and say never true. Okay, so hopefully with our explanation and being able to look at which terms need to move where, you can remember our ultimate goal from examples 1 and 2 are to get your variables on both sides or on opposite sides of that equal sign. And then 3 and 4 talk about really special situations. First being when there's no solution. Second, when there's infinitely many solutions. Now, can you check? Can you check? Yeah, you can. For the check, you can technically pick 2 values to replace your variable to prove it is always true. So you could pick any value for x twice, substitute in like a regular check, and show that it works both times, and that's your check to prove that it's infinitely many solutions or all real numbers. All right, have a great night.